Hey guys, Mr. Gibson here. So for this assignment, you are doing Explain 1.2. Remember, 1.1 in Unit 1 was just the structure of the atom. Now we're still in Unit 1, but this is the second section, so we're calling it 1.2. And we're not so much looking at the structure of the atom as we are looking at how the structure of the atom was discovered. How did we find out that there were electrons, protons, neutrons, that the atom even had a nucleus? We just kind of take that information for granted now. But that's information that we didn't know in human history up until very recently, relatively, like in the past 150 years. In the case of the neutron, we didn't even know about it until the 1930s. So this information that you guys learned in the first part of this unit, you probably just take for granted. Oh yeah, I know there's protons and electrons and all that stuff, but that's pretty monumental stuff that if you were to go back even 100 years, you would just absolutely blow somebody's mind if you were to tell them what you've already learned in this class. So this activity is just designed to explain everything to you, just to give you all the information in a way that hopefully you can learn it and internalize it, put it in your long-term memory. Okay, so there are actually 2 days to complete this assignment. Okay, originally I made this 2 separate assignments, and there was some confusion about where to submit stuff. So now I'm just making it one big assignment. But because it's such a large assignment, I'm giving you 2 days to do it. Okay, so hopefully you don't just wait to the last second on Friday to get it done. Hopefully you kind of pace yourself on Thursday and Friday, just taking your time getting it done. All right, so here's the instructions. You're going to open the attached PDF, which is your interactive notes, with Kami. All right, and then you're going to use the information on the Google Slides to fill in the blanks, just like we did before. So let's go ahead and open this up. That's going to look like this. It may automatically open for you. Again, I'm not really sure how it looks on your end, but you should either have this tab here, this is open with Kami, or you can click here and it'll say annotate or open with Kami, and you click on that. So let's open it with Kami and see what we got here. All right, so this is opening up our interactive notes, and here's what they look like. Okay, now there's not a ton of like chemistry problems going into this, not like the last one where you had to like look at an atom and tell me how many protons, neutrons. You had to figure out the isotope notation. This is very straightforward information. It's almost more history than it is chemistry, but it's important to understand how these major discoveries were made so that we know how to make major discoveries in the future. So, what you're going to do is you're going to use this information in here, and it's going to walk you through the major discoveries of the parts of the atom, the electrons, the protons, the nucleus, the neutrons, okay? Because people had some crazy ideas about what the atom used to look like. So these discoveries really helped us a lot. And you're just going to use the information to fill in these blanks here, okay? Now, in case you've forgotten, you may be thinking, what are these questions over here in the margin on the left side? Those are there to help you study. So when you fill this out and this activity's done and over with, and you're wanting to study for a quiz or for a test, you can come back here and challenge yourself to answer these questions, and it will help refresh your memory and help you dig up some of the information that you put in here that you may have forgotten. Same with these summary things here. Just a good study tool, because summarizing information in your own words is a really good way to put it in your long-term memory. Okay, so you're going to fill these out. There's 1, 2, 3, 4 pages of that. The reason there's that many pages is because there's a lot of pictures of people, so that took up some room. There's not a ton to actually fill in. And then you're going to answer the summary pages. Summary page, just one. Super easy, okay? To help you recall the information that you put up here. Now, once you've done all of that, you've filled in the blanks and you've filled out the summary page, then you're going to watch the rest of this video. So if you haven't done those things yet, pause the video and go do those things. Now, once you unpause the video, I'm going to go over the answers to the summary page to help you make sure that those are right. Not to help you fill it in for the first time, but to help you make sure that you got those correct, because I don't want you studying incorrect information, okay? So hopefully now you've paused the video and now you're back and all this is already done, and we can start going over these. I'm going to do it relatively quickly because, again, this is not designed to help you fill those in for the first time. You're just checking your answers. So Who discovered the electron? Well, the first guy you read about up there, the first subatomic particle ever discovered was the electron, and it was discovered by a guy named J.J. Thomson. Okay? And he used a pretty neat experiment called a cathode ray tube to discover the electron. And what this was is it was a tube. I believe there's a picture of it. Yeah, here we go. It's a tube. It's very simple. It's just a tube filled with gas, and it's hooked up to a voltage supply, so it completes a circuit. And you conduct an electric current through that gas. We actually have something pretty similar to that here at school that I'll probably show you when we come back in person. And what J.J. Thomson had the idea to do is he wanted to figure out this beam. So when he would conduct the current, when he flipped the on switch, he would see this beam go from the cathode, from the cathode to the anode, okay, from the negative end to the positive end, completing the circuit. And he had no idea what this beam was, and he wanted to figure that out. So he took basically a magnet, and if you know anything about a magnet, it's got a positive end and a negative end, okay? And remember, opposite charges attract each other, and like charges repel each other. So he took this magnet and he put the positive end up to this beam of light that was going through the cathode ray. And what he noticed is the beam started moving towards the positive end of the magnet. It was attracted to it, which should tell you that whatever that beam is made of is negatively charged. Now, just to verify this, he flipped it over, and now you have the negative charge, and the beam bent away from it, meaning that it's repelled, just further reinforcing the fact that whatever this beam is made of has a negative charge. And so what he was able to conclude was that this beam going through this circuit in that glass tube is not just some magical ray of light. It's made of something. It's made of particles, and it's made of particles that have a negative charge, and he named those electrons. Okay, that's actually how all electricity works. It's just the movement of electrons through something. So when you turn on your light, you're completing a circuit so that electrons can get to your light bulb and hit the filament and make it light up. It's pretty interesting. So he used a cathode ray tube. Now, what ratio was Thomson able to calculate? Now, he didn't have an experiment. He didn't have the apparatus to be able to tell us the exact charge and the exact weight of an electron or the exact mass. But what he could do is tell us the ratio of the charge to the mass. So he determined the charge to mass ratio. Okay, we don't have to go in depth on what that means as long as you just know that he discovered that. Okay, so J.J. Thomson discovered the electron using the cathode ray tube, and he was able to determine the charge to mass ratio of electrons. Now, someone else figured out the exact charge and the exact mass of an electron using a different experiment, and this guy's name was it makes me think of Milkman. It's actually Millikan, though. Robert Millikan. Okay. Robert Millikan was able to discover that, and he used an experiment called the oil drop. Discover the charge and mass of an electron, and you can see that in a picture here. So here's Robert Milkman, and here's his oil drop experiment. Okay. Now, so we've covered one subatomic particle, but remember there are two more. We've got electrons, but the next one is the proton. Who discovered the proton? It was actually this guy named Eugen Goldstein, or Goldstein, however you're going to pronounce it. It doesn't matter. Sure I spelled this right. I'm going to double check that I'm spelling that right. Yeah. Goldstein, Eugen Goldstein. Spelling's not my thing. So he discovered the proton. Super important discovery, because now that's how we identify all of the elements, is how many protons they have. So pretty monumental thing there. Now, who discovered the neutron? That was a guy by the name of James Chadwick. And that wasn't even discovered, the neutron, until the 1930s. So that's pretty crazy. My grandparents were alive before we even knew that there were electrons. So that's pretty insane. All right. Now, who discovered the nucleus of the atom? This was a guy, and you're going to learn more about him in the next part in 1.3, but we're going to introduce him here. His name is Ernest Rutherford. Rutherford with an R. Okay, yeah. And he discovered the nucleus of the atom using his gold foil experiment. Okay. That'll go down in that blank too there. So his gold foil experiment. And you're actually going to get to play around with this experiment in an explore activity in the next unit. So I'm not going to go super in depth, but basically they used to think that the atom was just mostly empty space with protons just kind of floating around in it. And so what Ernest Rutherford did is he shot particles at a thin sheet of gold. And so if the atoms really didn't have a nucleus and things were just the protons were just floating around, then the particles would just go straight through and never hit anything. But what he discovered is that they were going in and hitting something solid in the middle of the atoms and bouncing off. And he discovered that, oh, there's actually something really heavy and dense at the middle of every single atom, and that is the nucleus of the atom that you now know about and just take for granted that it's there, but he's the one who discovered it. Okay, so he concluded the atom was made of a small, dense nucleus, which was surrounded by a cloud of electrons. All right, so now this is just a little bit of matching. So Eugen Goldstein, he discovered the proton, so that is C. Number 10, Robert Millikan, remember he discovered the mass and the charge of an electron. So using the oil drop experiment, so that's B. Oh, sorry, that's A. And then Ernest Rutherford, he discovered the nucleus, which would be B over here. James Chadwick discovered the neutron, which is E. Where's my text box? And last but not least, J.J. Thomson, and I believe that J.J. Thomson discovered the electron, which is the letter D right here. All right, and there's your summary page. If you guys have any questions about what you've learned or about any assignment, feel free to email me. And don't forget to turn this in, okay, because this is going to be a big grade. All right, guys, thanks.